I am live. We are live. We are indeed live. Not a test, not a drill. Indeed, we are live. This is my hair. Some people have been asking if it is real. Indeed, it is real, as far as I know anyways. Um, this is a river behind me. This is the Cape Fear River. We are back outside and ready to do an outdoor live here with you right here, right now. So welcome one, welcome all. And I have this book with me as usual. For the past few lives, we've been covering Stephen Hawking's A Brief History of Time. Today we will walk first, and then we will do some reading and do some discussion. Hello Chickpea, hello Face, hello everybody. Thank you so much for joining. And can you please like the live? I am here next to look at you all dashing looking. Oh, thank you, thank you. Oh, thank you, thank you, thank you. I think people are gonna think that I am partially crazy, but thankfully it's a Monday and most people are hopefully otherwise occupied and not really out here, right now. And I can show you the sky, the sun, and the river and myself. And thank you so much for being here. Indeed, thank you so much for joining. Chickpea says chickpea. Face says hi. Chickpea says look at you all dashing looking. Thank you so much. Thank you for joining. And how are you guys doing? How are you? It's very sunny at the moment, so I think I'm gonna have my sunglasses on. But yeah, I'm also naturally drying my hair because I washed it and it has been kind of wet. But here it is. The sun will blow dry it for me. And in this moment, we can hang out. We can indeed join together and go live and discuss some things. So I'm rotating. Look at these bar stools right here. So this is a stone top little stool that you can sit on for free, and it is by this river, the Cape Fear River. And by the way, as soon as I've kind of said hi to everybody, I'm gonna go for a walk with you guys and you can see more sights. So that's what's going on today, my friends, my lovely people. Thank you so much for being here. Thank you indeed for joining. Mwah, mwah, mwah. Let's see these comments. We know you're crazy, but we love you. Oh my gosh. Oh, thank you, my friend. Thank you, Chickpea. Thank you, Ver. Yash says, you're absolutely stunning. Great heart, amazing looks. Probably the most beautiful person in the room. Maybe even the world. Goodness. Everyone's talking about it. Believe me, there's no one like you. Well, Yash, well, thank you so much. That is quite a lot. Thank you so much. Welcome to the live. Can we get 10 likes? Can we get 20 likes? Thank you so very much. NS says hi. Hello. 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 Chickpea says very correct, Yash. Good job. Oh my gosh, you guys are quite kind. You guys are being very kind. Beautiful, lovely people. Thank you so very much. Thank you, thank you, thank you. And as always, feel free to put something in the chat. I will say hi to you. I will read out your chat message. I will give a shout out to your username. So now's the moment. Put something in the chat right now and I'll read it and give you a shout out. Arlene says ciao. I was gonna say that as xiao, but I believe Arlene is saying ciao. Hi, Arlene. Nev says hi. Hi, Nevs. Gabrielle Luz says hello. Hello. Hello, 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 hello. Hello, 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 hello. Here is a sky, a sun, the air outside, and ooh, here's my dress. Here's a little necklace for the live. I did not purchase this necklace myself. It was indeed it was a gift. So, just saying, just saying. And here's the book that we've been reading, but we will start that in a moment after I say hi to everybody. So now is the moment, your moment, to say hi, hello, and put something in the chat and I'll read it out. Mike says hi from Budapest. Oh my gosh, welcome Budapest. And of course, I forgot to say hi to all my continents today. So thank you for reminding me, Mike. Nev says, where are you on holidays? Looks pretty sunny. Yes, I am on holidays. I am in North Carolina. It's very sunny. It is very sunny. It is actually, it's a cloudy day today, sort of. As you can see, there are some clouds in the sky. It's not the fully sunny and clear Carolina blue, but pretty sunny to me. If this is sunny, then I suppose sunny is quite all right. And here's some bar stools on this deck by the river. This is called the Wilmington River Walk. That's where I am. And look at those shadows. It means that the sun is a thing. Is that a dress? Looks really nice. Yes, it's a dress. See? See? Do you see? Yes, it's a dress. It's kind of a long dress, but it's a nice and sort of light dress, so won't get too hot. Sasha says, what's up? Hello, Sasha. How are you doing? How are you doing? Chickpea break says, hope you had a chickpea break. Actually, I just ate chickpeas. My family knows that I eat chickpeas and they have quite accepted it. In fact, they have now started to buy cans of chickpeas themselves. Ooh, thank you for liking the live, by the way. I forgot to say, can we get 10 likes? Can we get 20 likes? Thank you so much. I'm getting a little hot, so you might see me sweating because it's kind of sunny out, kind of hot out, but at the same time, it's quite nice as well. Faye says my head is tilted. Oh, that's so sweet. Hope you had a chickpea break. Yes, as I was saying, I had chickpea for dinner yesterday, a little bit part of the dinner. So because I'm eating with other people too now, the chickpea is not the whole meal, but I contributed for my part. The part that I prepared was the chickpeas, as you know, my favorite. So we ate some chickpeas and that was lovely, and then we had leftovers, so I just had that for lunch, and probably will also contribute chickpea to the dinner tonight, and then tomorrow I go back to Boston. Just saying, because I live in Europe and it's still snowing. I live in Austria. I haven't seen the sun in months. There you go, Austria. Here you go. Welcome, Austria. If you want to see some sun, here we go. La la la, la 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 la. Here you go. Here's some sun. Here's some sun for you, Austria. I understand the lack of sunlight can be a little bit depressing indeed, but here you go. You can always count on parts of the United States of America to give you some sun, because the sun is indeed a thing here sometimes, and in this state very much so. North Carolina gets a lot of sun. It's sort of in the south. It's sort of the beginning of the south, I think, pretty much culturally the south, I believe. Just saying. Oh yeah, Sasha says beer emojis. Thank you, Sasha, for the emojis. I don't know if I'll be drinking any beer today because, well, I'm trying to drink only a little bit per month. I don't drink a lot, but thank you so much, and cheers to you, Sasha. Cheers, cheers, cheers. David says, is that book A Brief History of Time? It looked like it. Yes. This book is A Brief History of Time by Stephen Hawking. We have been covering this book and talking about this book and discussing this book and the topics from this book and taking questions. So if you have any questions, if there's a topic that you would like to mention, go right ahead. We've been having lots of fun with it, and we're on the chapter called Origin and Fate of the Universe. In fact, it's very windy. Baji's watching the live. Don't be too happy. Oh, that's true. You're right. My babies. Well, my babies are with their grandmother. So indeed, you're right. But you're right. I do miss them so much. Miss you, Baji, Suji, Fuji. I love you so much. Mama loves you the best of all. Mama loves Baji, Fuji, and Suji. The best, the best, the best. More than the entire universe put together. And thank you, God, and thank you, universe, for Fuji, Suji, Baji, and myself. Thank you. Thank you, thank you, thank you. Welcome to the live. Welcome. Welcome, welcome. Welcome, welcome, welcome. Hello. Hello, hello. Shall we start walking? Does anyone have any questions? Physics questions, life questions, live questions, this book questions. If you have any questions, this is a great time. And if you're just joining and want to say hi, do it now. I mean, you can do it at any point, but feel free and most welcome to say something at any point. Nev says, what is this stream about? Well, it is going to be about us hanging out for a bit, and I say hi to everybody, and I read all the comments, and I give shout outs. And then we're going to talk about physics. We're going to talk about the origin of the universe and the fate of the universe. So, Big Bang, black holes, things like that. And if you're interested, you should definitely like, share, and subscribe. In fact, you should go ahead and subscribe now. I highly recommend, because well, this whole week we've been kind of covering black holes, and we're sort of getting towards the early universe stuff right now. We started that yesterday. Thank you so much. Usually I do my lives from my home with the kitty cats, so it's sort of a cats plus physics kind of channel. So I've got some extremely cute animals who are my babies that I birthed. So at home I have cats, outside I have me and, well, the world, and sometimes the sun and the river and the ocean and air and wind. And sometimes I even eat on the live, and I encourage people to eat chickpeas because they're quite easy to prepare. It's just what I eat, and some people have just taken note, and now it's a thing. And then mostly all the time we do discuss physics, astronomy, astrophysics, and cosmology. So that's what we do on the live. Cosmology is the study of the entire universe, especially and including the Big Bang, early universe, cosmic microwave background, expansion of the universe, dark energy, which is an unknown sort of thing, but is responsible for the expansion of the universe, dark matter, which is also unknown. So I'm kind of mentioning to you some of the things that we know about, and also some of the things that are active topics of research. So we talk about all that, which is cosmology. We also talk about astrophysics and astronomy, which is basically things like our solar system, but not really limited to that. It's more like the galaxy, other galaxies, types of galaxies, extragalactic sources of neutrinos, for example, or other cosmic particles or astrophysical particles. Stefan Parisian says, are you okay? And then popcorn. Thank you, Stefan. Nevs was asking what this stream is about, and I was answering that. I got pretty excited, so thank you for the question, Nevs. Murphin says, who dis? David says, very awesome. I have every book of his that I could find, and I'm on my second reading of A Brief History. He's a hero of mine. Oh, you will really enjoy some of our discussions then. We've been talking about his book for about a week now. And especially, of course, he worked on black holes, so that's going to be of interest to you. And feel free to put anything in the chat that you would like to share as far as the topic, anything you like. You know, if there is a specific topic in physics that you like about David F. Thank you so much. Thank you for coming to the live. Stefan/Stephanie. Learn on yourself first, and then meditation emoji. Thank you, Stephanie. Bro, Earth is legit. The center of the universe, says Murphin.
What are you doing?
Nev says, are we also talking about the wow signal and quasars? Very interesting theme. So this is a great question, Nevs. I have a live stream in the past called Active Galaxies, in which we have in-depth covered quasars among other examples of active galaxies. So quasar, or quasi-stellar or quasi-star, is a type of active galaxy with an AGN, or an active galactic nucleus. So a very active galactic center, which basically has so much luminosity where that particular active galaxy's galactic center can outshine or rival the luminosity of the rest of the galaxy. So if you have such an active site at your center where you could rival the luminosity of the rest of the galaxy, then you're categorized as an active galaxy. Now, quasars are an example of active galaxies. There's a couple other types of active galaxies that we also mentioned, and they sort of belong in their own category. Because back in the day when Hubble was finding and discovering all sorts of different types of galaxies, we basically categorized them or organized them based on their morphology or shape, which is the three types of galaxies that we know about: spiral galaxy, elliptical galaxy, and irregular galaxies. So spiral galaxy example would be the one that we're in. Milky Way is a type of spiral galaxy. The Milky Way also has a galactic center, which is quite bright, and we have a supermassive black hole, of course, at the galactic center. Now, this wasn't all obvious all the time. We've lived in the galaxy for a long time before we realized that this is the case, and indeed that there's this supermassive black hole which eats a lot of extra material, and this infalling matter can actually give off a lot of bright radiation in radio, X-rays, etc. So, but the Milky Way is a very wholesome galaxy that we are proud to be part of. It has a lot of other things as well, stars and whatnot. There are around 200 billion stars in the Milky Way galaxy, our own home galaxy. And so it is not the case that the galactic center is brighter or rivaling the brightness of the rest of the galaxy, for example, in our own galaxy. But there are certain galaxies, such as quasars or active galaxies, where that is the case. The AGN, or the galactic nucleus, is so bright. It may have jets coming out of it. It's basically this whole center of activity, and probably involves also some black holes and things like that, which then leads to the very bright center. So that's what a quasar is. In short, because we mentioned it here, I am not giving the full lecture on quasars today, but we have covered basically lectures on quasars several live streams ago, but I wanted to mention them in short, what they mean, since somebody brought it up, and they are quite a good question, quite a good thing to bring up. So thank you for that. Nebs, I believe, is who asked the question. Thank you. I have a question. One second. Oh, somebody said, Murphin said, Earth is legit the center of the universe. Now, so I don't know if you mean the solar system. So back in the past, we used to think that the Earth is the center, and we had a geocentric model for the solar system. We now know that indeed the solar system is heliocentric and the Earth is not the center. But if you mean the universe, I will say that there is sort of some truth to what you're saying, Marfin, because the universe is infinite, and right now, at any given point, because of its expansion, we actually mentioned work of Friedman, who worked on the expanding universe cosmological model. And you know, general theory of relativity was, of course, developed by Einstein. It was around the year 1917. So it's quite literally been over 100 years that we have his work, and a way to describe this universe where gravitation is part of the curvature of space-time. It's what curves space-time. So all of that is a thing. He also had to take into account a term for anti-gravity, because he realized, well, the universe is not collapsing on itself. Gravitation is countered by something. So he introduced a cosmological constant in his mathematics, which turns out over the next 100 years, we've made a lot of progress in understanding that that's dark energy. There is something that's pushing things out, and the universe is expanding. But Friedman was actually the first person who took this type of expansion and GR, general theory of relativity, at face value and developed these equations. And you might be interested in those if you are based on this comment, because you will realize that at any given point in the universe, pretty much the universe is isotropic. It's at any given point, you might feel like that is the center and everything around you is sort of infinitely expanding out. So in that sense, that is kind of true. And in the sense of the solar system, though, we have, of course, settled the matter a long time ago, from the time of Copernicus, that indeed we do not have a geocentric solar system, but more like a heliocentric solar system. But thank you for the comments. Thank you for joining. Thank you for all the questions, comments, chat messages. Lovely to have you. Lovely to look at this light above my head. Looks funny. Lovely to have you here. Welcome, welcome. And if you could please like the live, that would be wonderful. Can we get 10 likes? Can we get 20 likes? That would be amazing. I'm sort of yelling a little bit because I don't know if you can hear me very well. How's the audio? Because I'm outside and there is the river sounds and the air and the breeze and everything. I have a question. So I was thinking about isolating dark matter and using for the greater good of humanity. The thing is, I was stuck in a loop when figuring out the method of isolation. So my question is, will you be the first one I tell? When I get a breakthrough, I want you to get all the credit. Oh my gosh, absolutely. That's very kind of you. You should definitely tell me. You should come to the live and share with all of us exactly what you find about dark matter. That sounds lovely. Pretty much, as you know, dark energy, this is a finger, I'm trying to say number one. Maybe I should use this finger. Dark energy is the number one unknown of the universe right now. We don't quite know what dark energy is, but we do know that the universe is expanding and its expansion is accelerating. So, okay, I'm being eaten by some bugs, so maybe I'll move and go to another stool because I don't appreciate the bugs slowly gnawing at me. Maybe I'll be here. So, as you may know already, the number one biggest unknown of the universe is dark energy. We don't fully understand it, but we do know that it's responsible for the expansion of the universe. Sort of an anti-gravity kind of phenomena is what dark energy is. It has to do with cosmological models. So it's not quite the same thing as dark matter, which is the second biggest unknown of the universe. But it is still a bit of a mystery. And depending on the exact cosmological model that you use to describe the universe, you will have less or more dark energy. So that is the sort of thing that dark energy is. Number two biggest question, of course, I already kind of mentioned, is dark matter. That's what Chickpea is talking about. Dark matter is this extra mass that we find gravitationally to exist in the galaxy, in the universe at large. And we also think that it has a pretty important role in the formation of structure in the universe. Because remember how, the universe started off as the Big Bang and then had some stuff happening, expansion happening, but then ultimately about a order of millions of years later, we started to form galaxies and stars and whatnot, right? So this sort of thing happening at the scale of the universe is called large-scale structure formation, which led to us having these galaxies, and inside the galaxies, of course, there are stars and other things. That's what's going on with large-scale structure. And actually, dark matter, whatever that is, because it's still kind of an unknown what dark matter is, has an important role to play in large-scale structure. So that's the number two biggest question, is what is dark matter, followed by dark energy. So dark energy followed by dark matter. Those are the two top questions of this universe that any of us can really work on and research. And if you make any progress, then of course, do feel free to share in the live. Thank you. Thank you, David. I will keep that in mind. I've subscribed to you. Thank you so much. Murphin said, what would happen if I dropped a neutron star on accident? That's a great question. I'll come back to you, Murphin. Matthew says, hi. Hi, Matthew. Hi, Imran. Hi, Stephanie. Hi, Murphin. Again. Stephanie says, caring about likes. We can care about earthly things like likes and such. Stephanie, or Stefan, without losing sight of the big picture. Let's see. There's some really good questions here. We're all God's children. So let me go back. I just wanted to say hi to everybody real quick and make sure that I'm not missing anybody. I think I've said hi to everyone. Let me say hi again. Nevs, Murphin, Stefan, David F, Chickpea, everybody. Thank you so much for being here. Much appreciate. Thank you so much. And now let me go back to the questions because there are some good questions coming in, which I really love. So, somebody asked about neutron stars. Let me see. What would happen if I dropped? So, I don't know about dropping a neutron star because neutron stars... So, let me first say what a neutron star is, since there might be people who don't quite know yet. Neutron stars are basically a type of stellar remnant. So, some massive stars, not all, but some sort of more massive stars than our sun, for example, when they die, they will compress and collapse to a neutron star. So they won't collapse to the level of a black hole, but they will compress and collapse to the level of a neutron star. So there's really three types of stellar remnants. These are white dwarfs, neutron stars, and black holes. Depending on the mass, from lower mass to the highest mass of stars, you would either become a white dwarf or a neutron star or a black hole at the death of the star. So, and by you I mean the star. The star would become either a white dwarf or a neutron star or a black hole. The word neutron star has star in it. It's two words, neutron star, but really it's not a star. It's a stellar remnant. It's oftentimes it's actually a pulsar. It can have a very strong magnetic field. Neutron star mergers when there's two companion neutron stars, because sometimes these things have are sort of in a binary of companions. Oh, there's a little doggy coming. Hi. Aw, very pretty. So there was a little doggy there, and by little I mean a big doggy, which I love. So neutron star has the word star in it, but really it's a dead star. Really, it's a very compressed end state of a star that has died. Okay, and the radius of a neutron star is around 10 miles. So sort of at the size of Manhattan, you have something that is extremely dense, compressed, being sort of the dead body of a star. So very massive, but very compressed. 10 miles is really nothing for a star to compress down to. And then of course, the discovery of neutron stars gave a lot of hope to the people who were mathematically deriving black holes, because they said, well, if a massive star can collapse enough to go to a neutron star, then it could maybe even go to a black hole, which is even more compression and even more of an extreme collapse. So that's what a neutron star is. It's maintained by neutron degeneracy pressure. So it basically, you've got gravitation of the star that's making it collapse, and then you've got this neutron degeneracy pressure, which doesn't let gravity collapse it any further. So neutrons are fermions, and they don't want to get, neutrons and protons could be in this star, they could be in this object, I should say, compact object, and they don't want to get so close either. They've already gotten pretty close at the level of a neutron star. So there's some things like that, and we have actually covered these stellar remnants as well in detail in previous lives. But that's what a neutron star is. And if I dropped one, somebody asked if I dropped one, that implies that you'd have to pick it up. And even though they're kind of compressed and small radius, 10 miles is still quite big for us to kind of hold. And also, this would be very massive. So, I'm not sure how you would be holding it in the first place. But thank you for asking. This is a lovely question. It's crazy how nobody cares about God's children. You know, Stefan, I think it starts with one person. If there is a person or an animal that you care about, then that means that somebody does care about God's children. And so keep on keeping on. That should solve the problem. Space is really interesting. I really like that channel and stream. Thank you. David says we can hear you just fine. Thank you. Oh my gosh, thank you for the feedback. How can radio waves, radiation travel in the vacuum? Sorry if this is a stupid question. I only know a lot about radiation. Aha. That's a very good question. I see the follow-up question. Neutron star is very, very small. So let's say I could somehow hold one. No. So neutron stars are not holdable. They are around 10-mile radius. So I think what you mean is a black hole. So if you could compress something to the point of where you can hold it, and if it was a star to begin with, then that's more like a black hole actually. And even then, that would be kind of small for a black hole. I will say the black hole might be what you're thinking about. And it is true that anything with mass can actually be compressed down to a black hole. You would just have to compress it a lot. So, for example, even human beings have a Schwarzschild radius or the black hole radius calculation. You just have to plug in the mass. And the escape velocity would have to be the speed of light, and then you would get out the radius of that particular black hole. Now, as you can see, for human beings to become a black hole, it would be a very extremely small radius, but for stars to become black hole is not so ridiculous, because stars have so much mass to begin with that when they are compressed, they could be compressed to sort of a, you know, few mile, 10 mile, whatever, you know, depends on the black hole, depends on the star, of course. You could see how it could compress down to something sizable in radius and still be a black hole. So I think what you mean, Murphin, is a black hole where some mass was compressed down to the size of its Schwarzschild radius, because anything with mass would have a Schwarzschild radius. Any massive body can have a Schwarzschild radius, which is the radius at which it becomes a black hole, which is basically where the escape velocity from that massive object is the speed of light. And so I don't know about dropping one, because if you are that close to a black hole, if you go past the event horizon of the black hole, then time kind of stops for you. That's a singularity. So if you're dropping one, as in if you're really close to one, and if you go past what we call the event horizon of a black hole, then you would be in the black hole and getting sort of destroyed by the black hole. And it's a singularity, And we say that time stops at the black hole singularity, just like time started at the Big Bang singularity. This is sort of the opposite singularity where time just kind of stops. So your time is done at that point. And so I hope that the black hole takes you somewhere nice, because we will not be seeing you anymore after that. Because for observers outside of the black hole, we would just see you going in and that's it. We wouldn't see you coming back out. Neutron stars are approximately as big as Paris. Yeah, 10-mile radius. So 10-mile radius of a downtown city sounds about right. Paris, London, New York, Manhattan. 10-mile radius is the size of a neutron star. Hi Chickpea, hi Faze, hi Murphin, hi Stefan, hi Nebs. I forgot to answer. How can radio waves or radiation travel in the vacuum? That is because radio waves are actually a type of light. So light can actually travel in vacuum. So you know how the speed of light is a constant in vacuum? So, you know, the light can travel in different media, but it can travel just fine in vacuum. That's actually how we can see light from various sources like faraway stars, galaxies, our sun, etc. Light can travel just fine through vacuum. It's an electromagnetic wave. It also has a particle nature. It's either, if you think about it like a wave, then it's an electromagnetic wave. It's electric and magnetic fields that are oscillating and traveling sort of together. And perpendicular to each other, actually, the electric and magnetic fields, that is. But basically, in the wave nature of light, it's an electromagnetic wave. In the particle nature of light, it's photons. And no matter how you look at light, it can travel through vacuum just fine. And what's this? Sorry, I just read one of the other comments. And so radio waves is basically a type of light. So when we say light, generally most people think of visible light. This is the light that we can see around us. You know, this is visible light. This is white light actually that we're seeing, say from the sun. The light that we see, the light that we get is white light. There are some other types of light that's coming out of the sun as well. Like for example, UV rays. UV rays is a type of light with the frequency higher than visible light, right? So our eyes are designed to be able to see only certain wavelengths of light. This is called visible light or visible wavelengths. But those are not all there is to light. There are many types of light depending on its wavelength and frequency. So if you have longer wavelength light, then its frequency is shorter. And if you have smaller wavelength light, then you have what did I say it backwards? If you have longer wavelength light, then you'll have smaller frequency. And if you have shorter wavelength light, then you have higher frequency. So like gamma rays have very small wavelength and very high frequency and high energy. Radio waves are a type of light that has longer wavelength, smaller frequency, and smaller energy. So for example, microwave. You know how, I use the microwave a lot. As people know, I don't cook a lot, so my cooking is limited to the microwave. Microwaves are also a type of light. Microwaves are basically light of wavelength a little bit smaller than the visible spectrum. And then we have radio waves. Am I saying this right? Are microwaves? Yeah, microwaves are a little bit smaller than visible light, I believe. Look that up. Sometimes I might get it a little off, because I'm thinking while talking. Radio waves are definitely larger wavelength than the visible spectrum. So because our eyeballs are not like a meter big. Radio waves are basically of the order of meters, you know. So if our eyeballs were the size of, like, say, a room, then we could see radio waves. But our eyeballs are, as you can see, pretty small compared to a room. And so we only see visible spectrum of light, and we say visible light. And some people think that the visible light is light, but light is actually much bigger spectrum than the visible spectrum. There is microwaves, radio waves, gamma rays, X-rays, all types of light, which have all the same speed of light in vacuum, 3 times 10 to the 8 meters per second. And they might just have different wavelength and frequency than other types of light, but they all travel through vacuum with that same speed, which is a constant of nature. And by the way, that constant of nature leads to having special theory of relativity and general theory of relativity and so on and so forth. So it's a very important constant of nature, this speed of light in vacuum. So thank you for the question. That motivated me to talk a little bit more about that. So how can radio waves and radiation travel in the vacuum? That's because they're just a type of light. Just a type of light. They also are composed of electric and magnetic fields in the sense of the wave, and they're also made of photons in the sense of the particle, because light has wave particle nature. Actually, most things, turns out, have wave particle nature. Depending on how you want to treat it, it can either be thought of as a wave or a particle. So photons can travel just fine through vacuum, just like neutrinos. Neutrino is a type of particle. Can also travel just fine through vacuum. Electrons can travel just fine through vacuum. And so now just think about light as just another type of particle. It's actually a boson type of particle. It can travel just fine through vacuum. And that's basically radiation, and that's basically radio waves, among other types of light, such as X-rays, gamma rays, etc. Okay? It's just that radio waves are longer wavelength and gamma rays are shorter wavelength. So radio waves are going to have more of a wave nature because they're longer. As in, you might treat them, you might find that you treat radio waves more as a wave, and you might find that you treat gamma rays as more of a particle because they have very short wavelength. Okay. Ace Wolf, hello. Ace Wolf said, hey Baji. Hi Ace. Hi the Bears. Hello Bears TV. What about magnetar, says Marfin. So I think you mean pulsars. Things with magnetic fields that basically act like lighthouses in the universe. Is that a bangle necklace? Maybe. It's a necklace that's kind of short, yes. Have 2 stars ever collided? Yes, of course they have. Yes, indeed, Faze, but we will talk about it in just a second. Murphin says yes. No a magnetar, no black hole. Sonic says, where you live and how old are you? Well, this is North America. You can look at this river. Hopefully that gives you some geography. Well said, Chickpea. Take off the glasses. Microwaves is my favorite type of light because I use them to make my favorite food. This is very true. Chickpea is correct. I do use microwaves to heat up canned chickpeas, and I eat that for most of my meals. Hi, Donnie. Donnie says ciao. Hi. Ah. Hi, Sonic. You seem like a reasonable guy. The book called Atom by Dr. Lawrence Krauss is something that I was also reading for the channel, and unfortunately the library took it back. So indeed, We must have it back on the channel. Sonic, have fun with the others in the chat. I think there's plenty of people to engage with you here, and thank you so much. So let me answer the question about two stars ever collided. So it is very possible for two stars to collide, and I'll tell you why. So let's forget about stars. Well, we can talk about stars, but what I'm about to talk about is more general. It's true for stars as well as dead stars. So whether it's two stars, so because for example, our sun is a solo star, but there are star systems that are sort of part of a binary. It could be a star and a white dwarf in a certain system. It could be a neutron star and another neutron star. So in other words, two dead stars in a binary. It could be a black hole and a neutron star in a binary system. It could be a black hole and another black hole in a binary system, and so on and so forth. It could be a star and a black hole that's sort of orbiting each other, as in that star is not yet eaten by the black hole. So there could be sort of an orbiting situation where a binary system of two objects is orbiting each other. But generally speaking, these things have obviously a lot of mass, and so there is quite a high gravitational field that each one has, and they're basically orbiting the center of mass of these two objects, right? And emitting a ton of gravitational waves as they do this dance. This song and dance of the two binary companions, because it could be a star and another star, a star and a white dwarf, a star and a neutron star, two neutron stars, two black holes, one black hole, one neutron. That's why I'm just saying companions, right? Two companions in a binary. So because they constantly release gravitational waves, they actually come closer and closer over time. And this is something that we measured for a certain binary system as early as the later part of the 20th century. So I think it might have been in the year 1989. You have to go back to my live where I was talking a lot about the book Einstein's Cosmos by Michio Kaku. But the first sort of measurement of gravitational waves, what we call indirect measurement of gravitational waves, was in this form, where we basically saw the gap between two binary companions get smaller and smaller over time, knowing that they actually get closer and closer because they're losing gravitational energy. They're giving off gravitational waves. Now, later on, as recent as within the last 10 years, we actually have direct measurement of gravitational waves with the experiment called LIGO. So now this is even more confirmed. But indeed, these binary systems actually lose gravitational energy because they're giving off gravitational waves. They're basically bending space-time, in other words, right? And that gives off, that's basically like saying the space-time curvature around them is pretty curved, like a dent in space-time. And they lose gravitational energy and they get closer and closer, and eventually they will collide. So it's very normal actually for two binary companions to collide and become one. When such a collision happens, it's generally going to cause sort of a cataclysmic, explosive event, and after that collision, it may even reduce to something like a black hole or some other compact object. But in the brief moments after the collision, actually we get gamma rays as one of the signatures from such a collision. So this is sort of a roundabout way of saying that gamma ray bursts are transient events in the sky that we knew about for a while. I think it was in the 1960s or 1965 or so when we first discovered gamma ray bursts. Then we realized that all of them seem to be extragalactic, and very far, far away, and pretty much isotropic. There's no particular direction from which we seem to get them, etc. We just get them, we catalog them, that's about it. And they were sort of a mystery. Then we started to learn more about them, and we saw that what we call long gamma ray bursts were associated with hypernovae, or very large supernovae, which, as you probably know, is just the death of a star and the explosion involved in a star dying. And then the short gamma ray bursts, there were some shorter gamma ray bursts as well, and those were thought to be part of such collisions like the one you're asking about, which is two say binary objects, two binary companions colliding, like neutron star collision or black hole collision. And we, by measuring gravitational waves directly, we confirmed that that is indeed the case. Indeed, short gamma ray bursts come from neutron star collisions, or neutron star black hole, or black hole and black hole collision. So hopefully that answers the question, have two stars ever collided? Indeed they have. You should definitely look up the first direct measurement of gravitational waves by LIGO. If you basically Google that, you will see, I believe it was the first direct measurement was from neutron star and neutron star colliding. Again, neutron stars are not really stars, they're dead stars, but still pretty cool that we can measure gravitational waves as well as see gamma rays from such events in the sky. So indeed, that is a thing, it has happened, and we even measure these now. Which is, by the way, quite difficult to measure. It's not a trivial thing to measure these things, but we have started to, and we might even put a gravitational observatory up in space to do these observations even better. Okay, what's the next question? Let me go down in the chat and try to see. Magnetar stars are real, proven, and extensively researched on, but anyway, another more unknown concept is called weird atoms. Have you heard of either of these concepts? Weird atoms. I'm not sure that I know what a weird atom is. No. Thank you. Thank you, Morphin. Thank you, Nevs. The Atom book is $9 on Amazon. We need a super chat. Oh my gosh! You figured out that the Atom book is $9 on Amazon? Thank you. Thank you, my friend. I actually was gonna basically just buy it because the library keeps just like when the book is virtual, the library gives me very little time to keep the book. If we get a super chat, that would most definitely help with that book. But thank you so much for the information. I will probably try to buy it. Did you execute Sonic? No. I didn't execute anybody because I'm too busy answering these excellent questions that are coming from you guys, for which I am so thankful and grateful and delighted that I don't care who says what. Anybody can hate on me today. I don't even, I'm so very happy that I'm getting lovely physics questions that I can answer all day long, and love the engagement that I'm getting from everybody here. So if some people are hating, then that's totally fine. It's more than what can be handled here on this channel. At least they're gone. Oh no! Why would we want a hater to be gone? They are the most engaging clients ever. He dealt with himself. He's pulling the French Revolution. You can call me chickpea break or chickpea. What is the closest star to our sun? Oh my gosh! Faze has asked another amazing question. Nikolai Zatsev. Hi, Nikolai. Oh wow, Nevs has already answered it. Alpha Centauri and Proxima Centauri. Indeed, Proxima Centauri is the closest star to us. Next, after the sun, obviously the closest star to us is the sun, and after that it's Proxima Centauri. But Proxima Centauri is part of that system that Nebs has already mentioned. Alpha Centauri, and are they getting closer together? Probably not. $500 super chat if I could. Oh, thank you so much. Nobody hates on you while I'm here, Chickpea. Oh, thank you. Everybody, thank you so much for all your support. The supportive comments do mean a lot to me. Thank you so much. How nice of you. So, Proxima Centauri is still pretty far away. So the Proxima Centauri, Alpha Centauri system is not that close to us. What I can say is our galaxy is merging with our neighboring galaxy, which is Andromeda. So I'll walk a little bit, and then I can sit again and chat as I sit, or chat as I walk, whatever. But here's the river. So because I got tired of the sun right there. I hope I didn't leave anything. Okay. Here's the river, and then here's me. So basically we are a Milky Way galaxy, and we have our neighboring galaxy Andromeda that we have started to merge with. You won't notice this merger all that much because it won't be until I believe really when we get to experience this merger more is in the next 3 to 6 billion years. So it's not like it changes much for us at this time, but the thing that is the merger of interest is really our galaxy with Andromeda. And did you know that when we do merge with Andromeda, we will be part of an elliptical galaxy. So right now our galaxy shape is a spiral, and it's very beautiful. I'm quite sad about losing our spiral shape actually, because we're a beautiful spiral galaxy, and so is Andromeda. But once these two galaxies merge and have more entropy due to that merger, we will actually be part of a merged elliptical galaxy. So, and we will have more enriched interstellar gas and whatnot. The stars and such will probably not be really affected because there's so much empty space, or really interstellar space between stars, that in a galaxy merger, stars and whatnot, planets are not really affected much, but the interstellar gas medium between the stars do get more rich, and richer interstellar gas is very good. Gas clouds that are enriched with metals and good things is very good, because that actually leads to star forming regions. The gas clouds that are very metal enriched are considered to be star forming hotbeds. As you know, you might know, the Orion, I believe it's the Orion Nebula near us, is the close star forming region. We don't. What is this question? Nev said, thanks, Chickpea. Do we live inside of a black hole? Asked Morphin. Nev said no. $9 on Amazon, what a steal. You want to buy it and send it to me, Chickpea? I would be most grateful. Morphin says, you sure? Do we live inside of a black hole? That's the question. Okay. Nikolai says Tory, like Tory Black. Sorry, I'm just kidding. Who is Tory? Backed up by science, very questionable, but shockingly not disproven. Chickpea, where are you going? If you're walking in a circle around the table, that would be A tier content. Oh, so here is the river walk. I'm simply walking on the river walk. So there is the battleship. You'll see we'll pass the battleship. But I've actually done this walk in the past as well. On the channel. So here's if you can see, there is the battleship. I think it's so bright that I can barely see the screen myself. So, oh, thank you. Thank you for the laughing emojis. So I'm on the river walk. So now, the question of interest at this time, oh, there's a shop with dresses. It's called Spring Fever. Okay, I have too many dresses, so I should probably not buy any more. But there is a little shop with dresses right there. Too bad I saw it. Okay, so somebody asked, I think it was Murphin, do we live inside a black hole? So we don't know. The answer is we don't know whether we live in a universe, we know that, but whether our whole universe, we'll go here for a bit, maybe I can find a bit of shade because I've been walking in the sun for a while. Harper! Oh no! Can you not hear me? I just saw the comment. I can hardly hear you. Harper! I saw you eyeing that guy. Which guy? I'm just trying to pass. What battleship is that? I can hardly hear you. Now it's okay. Oh, thank gosh. Hey, Harper. Hi, Harper. How have you been? Also, can we get 20 likes? Can we get some more likes, please? That would be amazing. I've come here because I need a little bit of a break from the non-stop sun. I'm next to this brick building here, and that seems to be kind of providing some shade over here. And here's the little town behind me. She hasn't talked about whether we do or not. See you next time, Nebs. She needs a sun break. So whether we do or not, all I know is that we are in a universe. Whether our whole universe is contained in a black hole is, well, that's beyond me. I don't know is the answer. Our universe, if we believe in multiverse, where there could be multiple universes and maybe you could go to another one through a wormhole or something, then maybe we are all contained in a black hole. Maybe. But indeed, I don't know. So there is not a lot to talk about, Because the answer is, I do not know. So we know about the universe, we know about various things to do with our universe. Whether all of it is within a black hole, I don't know. Oh, it's kind of cool right here. Cool air is flowing. There's a little breeze. I haven't been here in a while because I have school and stuff. Thank you, Harper, for attending. We have missed you. Okay, now that I got a little break from the sun, I can continue the walk on the river walk and show you guys the river again. I am liking that it's much less crowded. So indeed, it's not like I have to avoid a lot of people, because it's a little weird, right? I'm just talking to my phone as I walk. Hopefully they understand that such is the job. Here's the river. Thank you everybody for your questions. I didn't do my reading yet today. If I can sit down somewhere safely without too much sun, then I'll do a bit of reading. Oh wow, there is a little cruise here that's starting. It's called Henrietta. Ship is sailing. It's a sightseeing sunset cruise that's getting started here next to me. I would show you more, but I'm giving privacy to the people. See? Little Henrietta starting off. Thank you for joining this walking live. I even see some mod presents.
I couldn't think of the word.
Chickpea, Harper.
Website looked very to me. It looked.
If you fall in a black hole, will it take you to a new universe? Not necessarily. If you fall in a black hole, it's likely you will die, and there might not be much more that happens. It may not lead to another better universe. We wouldn't know. See, information is difficult to get out of a black hole. So I wouldn't really count on it, is what I have to say there. I wouldn't really count on being able to go into a new universe when we fall into a black hole. I would count on, well, I don't know what I would count on, but certainly wouldn't necessarily expect a great outcome. It could be very violent for the person falling into the black hole because of enormous gravitation. Remember, a black hole is a singularity with infinite density and a very strong gravitational field that keeps light, as in bends light, bends space-time so that even light does not escape. So that type of gravitational field is, well, detrimental and produces tidal forces on objects nearby. This is apparent because we have observed this to happen with matter accreting into a black hole, even for the supermassive black hole at the center of our own galaxy, so we know this to be true. So accretion, tidal forces, all of this is quite quite normal. Oh boy, it's very hot. We just wouldn't make the trip. How would you fall in a black hole? Would it suck you up? Where's Steven? He needs to enjoy. Hi. Hi, I don't know. I don't know where Steven is. How would you fall? Well, if you were near one, you could, if you weren't careful, you could fall into one, or you could intentionally dive into one. Oh wow, look at this restaurant thingy thing. There's like, there's like little, oh gosh, I shouldn't stare. There's little balconies here, and those little, oh my gosh, I'm not gonna keep looking because somebody just dropped their cutlery, and this restaurant has a bunch of balconies. I don't know if you can see now. See behind me right there? There's a bunch of balconies, and each balcony has a nice little cute table that I believe people are eating at. What a great concept. Hi Sonic. I dare you to go into the restaurant as a chick, please. Okay. Station by me. Wow. But I think that guy. Oh, look. Boats right here. There's the bridge. There's the bridge. There's the bridge. There's some boats. There's somebody playing music. A lot is happening indeed.
Oh, I know.
But oh good, oh good. It's really great. Stuff happening is saying, what does this have to do with science? It's a walking science kind of live. It's a walking and talking about science kind of live, my dear. But look at this. Look at this. Look at the, I don't know if you can see the battleship. There's that as well. I'm giving my viewers a wholesome experience indeed, I hope. Here's some more stuff. But I can't believe this restaurant. I don't think I knew that the balconies are tables. Stuff happening, no worries. You can always rewind to the beginning of the live. We talked a lot. And if you have a science question, like a physics question, like black holes, universe, cosmology, astronomy, astrophysics, go ahead and ask it, and or feel free to rewind and catch all the discussion that we just did. There it is. Looks like a historic town. It is. Thank you. Thank you for subscribing. Can you also like the live? Can we get 20 likes? Can we get 20 likes, please? Thank you. I'm feeling quirky. That's true. Quirks are a type of particle that we have also discussed on the channel. I'm subscribing. Thank you. It is a historic town. Like this is one of the historic towns of the East Coast. It's also a port city. So because of the ocean and the water and everything, it's actually a very important port city. And so yes, there is history here. I wish that there was even more history, actually. But passing the courthouse now, United States courthouse. See? Alton Lennon Federal Building, there. Thank you. Go to a museum. Can we get 20 likes? Thank you, thank you, thank you. Thank you, Chickpea. Thank you, indeed. Look at all these nice palm trees. Oof. I will say that this is a little hot for me. I'm visiting, so I'm not used to quite this much warmth in the month of March. In Boston, it's a little cooler. But I might just prefer it because it's a little hot. Hi, love your toy. Love our toy pups. Hi. I was going to make a gold joke to my friend, but when they didn't get it, I just said, ow. A-U. Love it. I love your joke. Such a beautiful day. Yes. I never saw this mod before. This is Lover Toy Pops. Lovely to have you, my darling. Thank you for being here. Lover Toy Pops has a lot of doggy videos, and thank you for coming to our live. You're so cute. Oh, thank you. Thank you so much. Look at that sky. It's humid. I know Dora and Reese and Herbert. Yeah, so Chickpea Brick, I think you joined us in the last month or so, and the lives, we've been going live for several months, so we have fortunately made quite a few friends, and quite a few mods are possible. You might just see them. Girl, we're celebrating. Are you celebrating? What are you celebrating? I have this thing with my science teacher where we exchange a science joke each week. Oh, very nice. Hi, Toy Pups. We reached 40,000 subs. Wow. Congratulations. Happy to be a part of the team. Yes, we've got quite the team of mods at this point. It's really nice. Indeed, we have a lot of... Looking at some apartments. Wow, this is nice. Indeed, we have a lot of support, which is truly very, 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 very nice. I'm looking at these apartments. Wow. I do too. Like to share it. Oh my gosh. Thank you. Thank you, Toy Pops. Love our Toy Pops. Thank you so much. Thank you, darling. Love it. Love your support. Love the love. Can't wait to come to your live again soon. Look at this. Trying to give people their privacy here. There's the sidewalk. Hello. I always supported the mods. I was a mod before I'm... Yes. I was a mod before I was a mod. I always supported the mods. Okay. Okay. I'll turn back now and try to find a spot. Ooh. this nice water fountain thingy thing behind me. Look at that. Actually, we go across. We'll sit there. Maybe this water fountain sounds can be a part of the live. I think these are like apartments and restaurants. Let's see. Let's go here. There's a lot of steps. We'll cover. Look at that. It's a walking and talking live, guys. We're exploring together. All right, my dress is a little bit flying everywhere. No one is around though. Good. That's good. Share the live, guys. Thank you. Can we get 20 likes? Oh, look at this nice courtyard. Oh, it's quite a courtyard. Nice restaurant. I'll show you in 1 second. Pull down the dress. I am looking at this book. I went like this. Okay, look at this restaurant behind me. Look at all these tables. Fancy chancy. I never knew about this. Well, it's not like I live here, so I don't know too much. But look at this. All these fancy tables behind me. That's the battleship. Super rocks. Thank you. I will eat chickpeas there. 30 people listening to me? Yeah. This view? Look at this. Thank you. Someone. I thought somebody was over here. They're not. Thank you. Oh gosh. Someone who is funny like a bee. Beers. Someone who is funny says hi. Hi. Nabil. Hello, Nabil. Please like the live, guys. Yes, please. Could you please like the live? You're so beautiful and good. Thank you, Nabil. Can you please like the live? Can we get 20 likes? Oh, I need to pin that message. Let me pin that message. Where was the message from you, my dear Shifty Break? I'm sorry I misspelled it. Someone who's funny like birds. Oh! I'm sorry I misspelled it. No worries, darling. Someone who's funny like birds. Hello! Look at this battleship situation. Hope that they don't ask me to get a table here. I'm looking for it. Definitely not right now. It's the end of the month. I did the budgeting today and I'm quite poor right now. Whoops, there's my clasp. I did my end of month budget and there is not a penny left for anything. So posing is all I can do at these restaurants, my dears. Don't ask me to eat there. I did my budget. Where are you in Canada? America. This is North America, darling. Can we get a super chat? Oh my gosh, thank you. Thank you, thank you, thank you. Let's go here. Oh my gosh. You're glowing. Oh, thank you. That's probably the sun doing the sweat and suntan on me. show them the chickpea setup. I can't, I'm outside right now. I can't quite show you the chickpea setup right now. I'm traveling, but when I get home, I certainly will. We're in Canada. Oh, Twi Pops, you're in Canada? I'm in the US. This is actually North Carolina right now, but I don't live here. I'm just visiting. But can we get a super chat? Thank you. 100 euros here. Super chat up the place. Oh, thank you, thank you, thank you, thank you. Someone who is funny like Bird says, I'm scared. Of what? Scared of what, dear? Okay, here's the view now. It's buildings. Atom book. Here we come. I'm in Gaza. Oh no. Good luck to you, someone who is funny like birds. QT Patootie says, what is that? What do you mean, what is that? The building or Gaza? Gaza is a place. It's been in the news a lot, my dear. Atom book, here we come. Yes, very true. Very true. Very true. Very true. Very true. Little transport. Alright, quite a breeze here. You almost said it, chickpea. Exactly. Almost being the key word. Almost being the key word. Look at my fancy attire. Just having so much fun outside these restaurants. Just so much fun. Almost. So some people I think live here, like they live in these apartments, and some people are eating here at these restaurants. I think you're pretty close to a museum we can go into. Well, it's 5:23 p.m. darling, so I think museums are going to be closed. Do you know Zane officials? So we're not doing a museum today. It's already after 5. I don't know Zane official. What is Zane official? Honestly, this part of the town I have never actually come to before. It's like new to me. So you guys are finding out with me, or I'm finding out with you. Look at this pretty tree right here. Little pretty flowers. Me and the flowers. There's more. Spring is upon us. Ooh la la. Look at this. Spring level flowers. Welcome to North America. Here we have flowers. In case you were missing flowers. Walking and looking like royalty, but being broke because of budget must be a pain. Aw, being broke is okay. Being broke just means like I have a budget and I follow it, and that's how you like have money. If you spend all your money, you're not gonna have money. So it's good to have a budget and feel a little bit broke and walk around like royalty, because then you have, or hopefully continue to have money, because you didn't spend it all. It's good to save money. Good to save it. Okay, we're not gonna go over there. Although there are some more benches. Let's do a science museum tomorrow. Oh gosh. Okay, 1 second. Let me fix my dress. Oof. I'm a little tired. I'm a little tired right now. So tomorrow I actually go back to Boston. So someone who is funny says K. 5 more likes to 20. Can we get 20 likes? Thank you. Thank you, thank you, thank you. Oh gosh, this table is moving. We didn't quite get to this book today, but I had it with me just in case. But people asked so many good questions, so here we are. Someone who is funny is saying May Kasakua, maybe? Thank you for that. Anything else? Any last comments, chat messages, peoples, folks? We are doing a walking and talking live, indeed. Indeed we are. Taking a little break here. Look at these cute tables. That's what I'm at. This little spot has cute tables. Sorry, it's Kazakhstan. It means I'm Kazakh. Welcome to Kazakhstan. Lovely to have you here, my darling.
Sorry.
Hi.
I need to study.
Oh, no, you're fine.
No. You had enough couple dollars while you get something to eat on
I don't. I'm sorry. Sorry, I don't have any cash on me. Yeah. Yeah. It's okay. The sun is still out. I don't think I will go over there because it's, yeah. I think I'll go back towards the river walk. You match the trees behind you. Yes, I do. The spring colors. Just be safe, Chickpea. I hope you're walking towards. You're right. I do need to walk back. I'm being expected for dinner, so I do need to go back. She just got. Well, she wanted a little bit of money, and then she left me alone. So it's all good. Just checking to make sure that I'm alone, because I'm a little distracted because of being on the live. So the sun is right there. Barely see. YouTube added a new emoji. Ooh. Yeah, it was just a lady who wanted a couple of dollars. As you know, I don't have a couple of dollars, especially not in cash form. Look at this water fountain. Actually, I'll keep going. I don't know if you can see. I think you'll see it in a minute. Hope I don't get a headache from the sun. Sometimes I get migraines. Oh, there's the plane. See that? Guess I look like I could have money. Whoops. Stay hydrated. Probably do need to get a water. It's been a lot of walking around in the sun today. Ace Wolf says Baji hi. go home soon. So pretty. Thank you. Show you the plane. Well, it's gone. Went fast. Lots of military planes flying overhead. This is North Carolina. Guess where? Show me the plane. Already gone. Beantown or where? What's Beantown? Oh, Boston. No. I'm traveling. Go back to Boston pretty soon here, but it's not Boston right now. It's Fort Bragg is closed, but yeah, not quite Fort Bragg. Good guess though. See the sky? Sunlight block right here. Fayetteville. No. Well, the planes may be going there, but this is not Fayetteville. But there's another one. There's another one. You can hear. The planes might be going there, but not Fort Bragg. All of that is close enough, though. Oh yeah, another military. Yep, went that way. Oh, sorry. Hi Chickpea, hi Eastwood. Hi Cara, how are you? I know I can flip the camera, but I don't want to flip it right now. I know I can flip it, but choosing not to at the moment. Because there's people and I want to give them privacy. Flip it, you'll see more of the other people who may not like it. Hello, Cara Halios. How are you? Bye, someone. See you next time. Please do like and subscribe. Like, share, and subscribe. Thank you. Can we get 20 likes? Gosh, the sun is... At least I'm walking closer to home now. The sun is beating down, beating down, beating down. Ah! There's the water. Thank you, Chickpea. Appreciate you and all your hard work today. Lots of service from Chickpea Break. Lots and lots. Oh gosh. I think we'll finish up the book this week. It's only Monday. I think we'll finish the book this week. And since you insist, we will definitely bring the Atom book back. I'll have to figure it out. I think I'm just gonna order it. Is the paperback $9? Because I really want it to be the paperback. I don't want to deal with the Kindle or whatever. I don't really want to deal with like a virtual book. Much rather it be a paperback like this. Like this. You know what I mean? Lots of service from that book. Also being used as a sunshade. That's true. Can't read the book because it's my sunshade at the moment. Lots of stories from that book also being used as a sunshade. I'll go check. Ooh, that's a great comment. That's a great suggestion. That's a great suggestion. You should take us to a science museum in Boston, like a field trip. Yes, indeed I will. Indeed. Some flowers. And the musician. Indeed I will. Indeed we should go to a museum together. Oh my gosh, that's a great idea. Hopefully that's allowed. Hopefully they don't kick me out. Good thing I'm not too famous. But we'll definitely try to do a field trip that involves a science museum. More river. Your teacher day one. Oh, thank you. Thanks for the encouragement. Yeah, I hope not. I am trying to teach about these things, so hopefully they get it. Ooh, maybe I'll go to MIT Museum. It's cool, I've heard. The MIT Museum. I can certainly try that. That could be nice. Yeah. Oh gosh, the view is excellent. Look at this. Whew. I'll show you this view for a brief period. Look at that river. Pretty cool. Oh, really want water. I could use some wawa, some agua, some pani. Pani de do bhai. Pani de do. But yeah, the camera on me is good because there's a lot of people passing now. It's a more busy time at this time. I wouldn't want to accidentally shoot them with my camera, that is. Any last comments or messages, people? Let me know. The Kindle is $10. The hardcover is $8.41, and the paperback is $20. What? The Kindle is $10. The hardcover is $8.41, and the paperback is $20. Wow. Well, I guess I'll get the hardcover. Can we get $8.41, please? And 20 likes, please. Can we? I can't believe this. Why is the hardcover more expensive? It is the more annoying version of a book. I will give you that. But the hardcover is literally more expensive. Wow. Or sorry, no, not the hardcover. The paperback is more expensive than the hardcover. Okay, there's a lot of pollution happening here. Henrietta. I can smell it. The Kindle is $10. Okay, I'll get the hardcover, $8.41. Can somebody donate $8.41 and give us 20 likes? Thank you so much. Thank you indeed. Kindles. I can't get over that. The paperback is more expensive. Of course it is. Of course it is, because the paperback is the only decent way to read a book. It's the only decent way. What else is up? Any last chat messages, comments? Guys, let me know. Let's go live later and squeeze some pockets. Okay. I see. I see what you're saying. Let's go live later and squeeze some pockets. Certainly. Since you're an author, will you write a book for someone? Yes, of course. A book for who? You guys? Certainly will. Yes, indeed. Certainly. Absolutamente will write a book for you guys. Having multiple books. Multiple. Why one? Multiple. Okay, I'm back to the river walk. So it's a bit more of a crowded, lots of people here kind of place, which I think is good. I don't really want to be in a dead part of the town where I'm ambushed. Although it was fine. That thing was alright. I want to be an honorable mention in that book. Aww! Of course you'll be an honorable mention. I think people think I'm crazy. People are looking at me like, this lady is... It's me, the river, and my talking. Hopefully that's alright. People are a little bit staring, which is good. As they should. As they should. Giving him something to do, you know? Can we get 20 likes? Come on! Also, I want to thank everybody. Oh, and I never said good afternoon, good morning, good evening, good night, good day indeed to all the continents. Asia, Europe, Africa, South America, North America, Australia, New Zealand, Antarctica. Anything else I missed? All the oceans, all the islands, everybody. Thank you so much for being here. Thank you for the likes and the subscribes and the shares. Thank you indeed. And thank you for joining. Thank you for the questions. We will continue next time. I hope I don't fall into the river by being distracted. If you're seeing this as a video upload later on, I do hope that you will leave your comments, your chat messages, and your thoughts under the video upload. Looking forward, can't wait already, and thank you so much. Ooh. I will go back to where I started the live. Back to those stools. 1 second. Crossing the people here. Faze, thank you for joining, everybody. Thank you so much. I'm gonna go over to the stools and then say bye, okay? I'm pretty close. I just tripped. I'm pretty close. Thank you for your comments. If you're seeing this as a video upload later on. Thank you, Heike. Thank you, everybody. Much appreciate, my darlings. Thank you, and see you next time. Here is Pilot House. Here's a restaurant right here. Hopefully they let me eat there for free next time, and then our life can be over there in the more, you know, calm and quiet. Oh, goodness gracious me. Be safe, Chickpea. Thank you. I'll be okay. Don't you worry. Okay, let me sit down for a bit and say bye to everybody. Okay. Bye bye. Bye bye. See you soon. See you soon. Bye bye. Bye bye. the river. Thank you everyone for joining. See you so soon.